Hello students, welcome to video 3 of module 2, D-type bytes tables. Here the letter D stands for data or the delay. What do you mean by data? So whatever you apply at the input, the same thing appears at the output. So that is the meaning of the data. Whatever you apply, suppose if you apply 1 at the output, you will get 1. At the input, if you apply 0, the same thing will be transferred to the output. Then the delay. So the input will be transferred as the output. So after some propagation delay time, always there will be a small time delay while transferring the input to the output. Here we will include one more input called as the clock input. So D is the data input. So this clock is for the synchronization. The data input, whether it is logic 0 or logic 1, is clocked into the bytes table such that the output state only changes when the clock changes the state. When the clock changes the state, then only the output should change. When there is no clock, the output will not change. How the clock looks? This is the train of clock pulses. Here they have considered this D-type bytes table changes the output during the rising edge of the clock pulse. This is called as the rising edge. Whenever the clock pulse changes from 0 to 1, it is called as the rising edge. Here this is called as a falling edge, where the clock pulse falls from 1 to 0. The D-type bytes tables are used both as latches. Latch means a simple memory cell where the output is latched either to 1 or to the 0. Or they may be used as binary dividers. In the later videos, we will discuss these binary dividers. Let us see the D-type bytes table. Here is the D-type bytes table where D is the input. This is the clock input. The output should change only when there is a change in the clock pulse. Here the D, here is the clock. The output Q, if you want, you can write the Q bar also, complementary output. The output changes only when there is a rising edge of the clock pulse. Here we are assuming that whenever the clock rising edge appears, rising edge means whenever it changes from 0 to 1, then only the output will change according to the input. Otherwise, there will be no change. So this is the diagram. I don't think you have any doubt with the diagram. D is the data input. Here is the clock. Here is the Q output. If you want, you can write Q bar also, no issue. State of the D input clocked to the Q output on rising edge of the clock pulse. The state of the D input is clocked to the Q output during the rising edge of the clock pulse. So how to understand the operation of this? So we will go with the timing diagram of the D-type bytes table. Here we have written the data input, what we are going to apply to the D-type bytes table. Here some input we have taken, no rule that you should write only this, you can write the other input also. Here we have considered this is 0, D is equal to 0, this is D is equal to 1, here D is equal to 0. And here we have applied the clock pulse, Here is the clock 0, 1, 0, 1. And also we have assumed this is sensitive to the rising edge of the clock pulse. The output changes during the rising edge of the clock pulse. In the clock, see where is the rising edge? Here is the rising edge, here is the rising edge. Even though the input changes from 0 to 1 here, you can see output does not change. Because here the clock rising edge has not appeared at this instant of time. Only when the clock changes from 0 to 1, only when there is a rising edge of the clock pulse, the output changes. Otherwise, the output will not change. So output earlier it was 0, so it maintains the same state. But here we have applied the clock rising edge. So at this instant it checks the input, data input is 1, so the output changes to 1 and it retains the same one state till the next rising edge of the clock pulse. It checks the input at the clock rising edge. Here is the clock rising edge. At that point, at that time, it checks the input. The input is 0, so the output changes to 0. So depending on the clock rising edge, the output changes. If you observe here, the data input falls from 1 to 0. Here the data has become 0. Here the output is not changing from 1 to 0 because we have not applied the clock. According to the clock, the output changes. So these types of circuits are called as synchronous circuits. They are synchronous with the clock. Only during the rising edge of the clock, the output changes. Otherwise, it will be stable. Here it has changed from 0 to 1. It maintains the one state only till the next rising edge of the clock appears. Next, it becomes 0. This is about the data bistable. Remember, D means data or the delay. So whatever you apply at the data, it appears at the Q output only during the rising edge of the clock pulse. And this is the timing diagram. Thank you.